In this video, we are going to explore the concept of the rate of chemical reactions, which refers to the speed at which the reactants in a chemical process are converted into products. We will also look at how to measure this rate accurately and how to visually represent it using graphs. To begin with, it is important to understand that reaction rates can vary greatly. For instance, a slow reaction could be something like the rusting of iron, a process that can take many years or even several decades to occur. On the other hand, a more typical reaction might be the one between magnesium and an acid, which produces a steady stream of hydrogen gas bubbles over a few minutes. At the far extreme of the spectrum, we have explosive reactions such as those that happen in fireworks, which are completed in a fraction of a second. To actually measure the rate of a reaction, we need to either measure how quickly the reactants are being consumed or how quickly the products are being formed. The quicker this transformation takes place, the faster the reaction rate. We can express this using two equations. One equation says that the rate of reaction is equal to the quantity of reactants used divided by the time it takes for the change to occur. The other equation states that the rate of reaction is equal to the quantity of products formed divided by the time taken. These quantities are typically measured in grams or cubic centimeters, and time is measured in seconds. For example, if we conducted a reaction where magnesium reacted with an acid and produced 180 cubic centimeters of hydrogen gas in 2 minutes, then since hydrogen is a product, we would use the second equation. First, we convert 2 minutes into 120 seconds, and then we divide 180 by 120, giving us a reaction rate of 1.5 cubic centimeters per second. In a different example, if 3 grams of magnesium were completely used up in 4 minutes, we would use the first equation. 4 minutes is equal to 240 seconds. We divide 3 grams by 240 seconds, which gives a rate of 0.0125 grams per second. It is important to note that these calculated rates are average or mean reaction rates, representing the overall speed throughout the whole reaction. In reality, most chemical reactions do not proceed at a constant rate. Typically, the reaction starts off rapidly when there is a high concentration of reactant particles available to collide and react. As time passes and the reactants are used up, the reaction slows down gradually. We can illustrate this behavior more clearly by plotting graphs. On these graphs, we place time on the horizontal axis and either the mass of reactant remaining or the volume of product formed on the vertical axis. For example, on a graph showing the mass of a reactant like magnesium starting at 3 grams, we would see a sharp decrease at the beginning, which gradually flattens as the magnesium is used up. Conversely, on a graph showing the volume of a product like hydrogen gas, the graph would begin at 0, rise steeply as the gas is quickly produced, and then level off as the reaction slows down and eventually stops. In addition to grams and cubic centimeters per second, other units can also be used, such as moles or decimeters cubed per second, or even per minute depending on the context. For instance, if we are told that 0.6 moles of magnesium are used up in 2 minutes, we would calculate the rate in moles per minute by dividing 0.6 by 2, giving us 0.3 moles per minute. This is exactly the same calculation as before, we just need to be careful with the units requested in the question. That concludes this explanation of how to calculate and understand the average rate of a chemical reaction. In our next video, we will learn how to calculate the rate of a reaction at a specific moment in time rather than averaging it across the entire reaction. If you enjoyed this video and found it useful, please give it a like and subscribe to stay updated with our upcoming lessons. Thanks for watching, and we will see you again soon.